I would like to welcome this afternoon Dr. Glyn Williams-Jones. Glyn focuses on physical volcanology and the processes controlling persistently active volcanoes. His current research integrates the study of geophysical signatures with geochemical and remote sensing data to investigate precursory signals to volcanic activity and the mechanisms that trigger eruptions. So I will be bringing Dr. Glyn Williams-Jones on and to talk about volcano risks. Welcome, Dr. Williams-Jones, or WJ, I'll call you.
Thanks. Glyn's
Thank you.
fine. Yeah,
Glyn's fine. Okay,
yeah.
thank you.
We're an
I,
informal lot.
yeah, great, fantastic. Well, why don't you give us a brief uh, introduction on what SFU does around earth sciences and particularly the Center for Natural Hazards Research.
So, in the Department of Earth Sciences at SFU, we cover the full spectrum of geology, glaciology, a strong component on geotechnical engineering, and obviously hazards uh, writ large. And obviously, my expertise is very much on volcanology. Um, the Center for Natural Hazards Research, of which I'm co-director, um, is broader, obviously, than the department, and we bring in experts from other departments in SFU, but UBC, UVic, and internationally, and really trying to act as a vehicle to bring people together to collaborate on areas of interest. So, from engineering, from the fundamental STEM sciences to social sciences. So it really does bring everything together. And so we've actually been trying to ramp things up and launching a number of large grant proposals to fund more instrumentation and more fundamental and applied research into natural hazards, especially focused here in BC. We have the mountains, we've got the floods, we've got the wildfires, and yeah, we've got some volcanoes as well.
Mhm.
So it's a great place to study natural hazards, and while we wait for the big one.
The big eruption or the big earthquake or both?
Well, yeah,
Sure.
more likely the big earthquake,
The
but
big earthquake,
you
yeah.
never know with these eruptions.
Yeah.
Yeah.
So and yeah, the reason I had brought you on was mainly because of the volcanoes, and I don't know if it's something that we discuss enough within disaster and emergency management, at least east of British Columbia. So what is it? What is the current hazardscape for volcanoes and risks related to volcanoes between maybe Canada, where you are, and even the northern United States?
Yeah. So obviously, I mean, this is one of my little soapboxes that I've been working on for a while, is trying to actually get volcanoes onto the radar,
Right.
both politically and socially. Most Canadians don't realize that we have volcanoes. Just like any natural hazards, they don't really follow international boundaries and borders. And volcanoes, especially, can be multinational, in fact, on their impact. If we think of the 2010 eruption of Eyjafjallajökull in Iceland, that
Hmm.
had global
Yeah.
impacts. Here in sort of the Pacific Northwest, both in Canada and the US, obviously the volcanoes in the US are much more active. We think of Mount St. Helens, the eruption in 1980 being a larger one. But the volcanoes don't stop at the border. They actually keep carrying north, and the whole Cascadia Range, which is responsible for Cascadia Arc, the same reason that we're expecting a large earthquake, well, those volcanoes are associated with that. So the volcanoes in the US are much more active, but we do have recent volcanic activity, geologically speaking, very, very recent. My group's been working on a volcano in northwestern British Columbia called Seax,
Yeah.
very small, innocuous little volcano, but it created a 32-kilometer long lava flow that was channeled in
Wow.
river valleys. It wiped out three First Nation villages, potentially killed up to 2,000 people. So that would make it one of Canada's worst natural disasters.
Yeah.
Um, this happened in the 1700s, so
Yeah.
very recent. Um, Closer to home, more on the explosive side of things, our Mount St. Helens is called Mount Meager. And Mount Meager, it's just 160 kilometers north of Vancouver,
Hmm.
and it erupted explosively on the same scale as that of the 1980 eruption of Mount St. Helens,
Okay.
only 2,400 years ago. Now,
Okay.
that's geologically yesterday.
Yeah.
Um, and we now know that there is volcanic gas melting ice caves through the glacier on top of it. So it's an active system. It
Okay.
also happens to be a big rotten mountain that is falling down. And so it's the site of Canada's largest ever landslide in 2010, bigger than Hope, bigger than Frank. We're looking at 53 million cubic meters of rock that failed,
Wow.
forced at least 1,500 people to be temporarily evacuated in the Pemberton Meadows area. So, we're into this system, and Meager is interesting in that way of cascading hazards, one hazard leading into the other.
Okay.
So,
Do you guys have is there a map published with their locations?
yeah, the
There is?
Natural Resources Canada has maps with all of the volcanoes being
Okay.
published. Um, the big problem on the volcano side of things, but also many of the natural hazards, and this goes to your question. I'm taking a long way to get
It's
to it,
okay.
but it goes to the question of where are we in the hazard space. One of the issues that we have is unfortunately still insufficient monitoring. So as of yet, we basically only have the broad earthquake network, the tectonic network, to monitor the volcanoes, and that's
Okay.
insufficient.
So you're
Um,
using the earthquake monitoring
yeah,
as the primary to, okay,
yeah,
to essentially
for
try and manage a totally different hazard.
totally.
Yeah.
Um,
Okay.
Bringing in obviously satellite monitoring now, this is becoming much more powerful and important, but it doesn't have the same repeat time. So the latency in the response is a problem.
Yeah.
But
Does it
that
measure
is
heat? The satellites do heat?
um, the satellites can do heat. The What's more meaningful is actually a deformation. So the satellites,
Okay.
if we use a radar, and it's a special type of radar called basically synthetic aperture radar.
Yeah.
The beauty is the radar goes through clouds, snow. It doesn't matter whether it's day or night,
Okay.
and
Yeah.
you can detect minuscule changes on the order of millimeters of ground movement. Maybe it's inflating because the volcano has got magma coming into it, or more likely what we're seeing in the case of, say, Mount Meager
Yeah.
is the flanks are slipping and moving.
Okay. Okay.
So that's a very, very powerful tool as well. But like any natural hazard from a monitoring perspective, it's got to be multifaceted. It's got to be multi-layered to pick up different precursory signals. And so
Sure.
we've got a long way to go to even come close to the level of monitoring that the USGS, the United States Geological Survey, does for their volcanoes.
Okay.
So you know that's sort of part of the effort is to try to up the game a bit.
Right. And so like you were, so we'll just dip into that now. You were mentioning earlier trying to get citizen scientists to push out a network of sensors.
Yeah, this is something I'm really quite excited about. And again, it goes back to my personal biases. Expensive instrumentation, a $30,000 seismometer that you deploy onto a volcano, which then erupts and destroys your sensor. That's a problem.
Hmm.
But the flip is, what can we all, if we have very expensive sensors, inevitably we have very few of them, just budgets. Where I'm quite excited is the this rapid evolution of low cost sensors that are actually quite powerful. They're not at the same level of the gold standard of our seismic system, but for a bronze standard, they can actually do a pretty good job. And so many of your listeners might have heard of a unit called a Raspberry Shake. It's a
Oh,
$600 seismometer
yeah.
Kickstarter started in Panama by a seismologist. Well, scientists are using this all over the world because they're low cost. And so you can go and deploy it. You can use it for teaching, but you could put it in your home and start to bring in some of the citizen science
Right.
aspects. So, or you can stick it on a volcano and it erupts, and who cares? That gets destroyed.
Yeah.
It's not a big deal because you've
Yeah.
been able to buy 50 of them for the cost of one of your sort of gold standards. So you start to be able
Oh,
to densify your network and tolerate a certain loss.
okay.
But where I'm really excited is, can we bring the citizen scientists, people who have skills, have expertise, and interest to come in and help develop this. So we're trying to bring a number of these off-the-shelf sensors and bring them together into a unit to study flooding, stream gauges, particle sensors to look for smoke in the air from wildfire, earthquake sensors, infrasound to listen for snow avalanches or rockfall. So there's a lot that can be done, and I think we'll be in a position to be able to bring a whole bunch of these sensors together for maybe $5,000 as opposed to $50,000 for one unit.
Wow.
And
That's actually pretty
yeah,
good. Yeah. So I know we have different people with a disaster and emergency management backgrounds, different roles. What, let's say for municipal leaders, in BC, Alberta, Pacific Northwest, what should they be including in their hazard identification risk assessments around volcanoes?
yeah. So volcanoes are, especially in the Canadian context, um, volcanoes have a wide variety of hazards that they can produce. You can think of, again, the Mount St. Helens is something that many people are familiar with. There was the large eruption column, that sent ash 15, 20 kilometers up into the air. Now, Mount Meager in BC did exactly that same thing, and in fact, sent ash basically 550 kilometers east. So it
Wow.
reached Calgary.
Yeah.
So there you have a situation where something is on the other side of the border,
Yeah.
and yet it's impacting you.
Yeah.
And that volcanic ash will get it's not like fire. It's not a carbonized wood. This is fragmental rock and basically volcanic glass. So that material, by the time it gets out to Calgary, we're not worried about the heat anymore,
Yeah.
but it's highly abrasive. It will get into electronics, machinery, people's lungs. So there's definitely an issue there. So it where volcanoes are a bit unique is you have these proximal hazards to worry about and distal hazards. So the
Mm-hmm.
volcanic ash being a broader impact, but proximally you can start thinking about lava flows, or in the Canadian context where many of our volcanoes are covered in ice, we melt that ice and we
Okay.
form what are called lahars, essentially a very dense mud flow. Think, 75% of that material being solid material. So the analogy is a river of concrete, highly erosive, flowing down channels, and then causing secondary knock-on issues like flooding and things like that. And then you've got associated earthquakes that can be destructive locally, volcanic gases coming out pervasively through the ground. So there, again, one of the areas that we need to do a lot of work on to enable emergency managers to be able to respond to these types of things is much more detailed work on developing natural hazards and hazard impact maps for these volcanoes. To date, we basically don't have any. So one of my
Nothing.
MSc students is building Canada's first volcanic hazard map for Mount Meager. And ideally that will be expanded, and the framework that she develops can be applied elsewhere.
Okay, so I just decided to pull up a map here of Western Canada volcanoes, just
Mhm.
so people could get some awareness of maybe where these are, because I'm really interested. So for those that are from the States, this is British Columbia mainly, and you can see the Alberta border here. But so all those red triangles are volcanoes, are
Correct.
they? Yeah.
Yep. So the red triangles and the red stars are
Holy
what we would
mackerel.
are more active volcanoes. So active in the sense, or more recently geologically active.
Wow.
So you can see that there are distinct belts of volcanic, systems. The
Yeah.
Garibaldi volcanic belt is the northern component of the Cascade volcanic arc. And so it goes from Mount Baker Glacier Peak in the U.S. All the way north to Mount Meager. Then
Wow.
we jump across. We can see the Anaheim volcanic belt, and there's some interesting stuff. Actually, the volcanoes get younger as you move eastward. So
Oh,
there,
okay.
yeah, and then we jump again to the Stikine, or it's now being renamed the Northern Cordilleran Volcanic Province.
Okay.
This belt number three, and there we have some real monsters, mounted Zaidza, Hoodoo, again these big glacier-covered volcanoes, and the youngest one, this one that I mentioned, CX volcano, which erupted in the 1700s, is right at the southern tip of that belt.
Wow.
And again, it carries on into Yukon and Alaska.
Yeah. And so we've got a question here from Tobias around the respiratory component of volcanic ash. I don't know if you can see that
Yep.
there. Yeah.
Yeah, so the respiratory is definitely an issue, and it really does get down to proximity, uh, and there's actually a lot of overlap, I think, in terms of response to how we deal with the respiratory issues around wildfires. So the same people that are already got, say asthma or other issues, I guess we would say comorbidities. Those would be important to sort of manage. But yeah, so the same approach: wearing face masks, staying indoors where possible. In some areas, there's also the issue if we're thinking about volcanic ash here on the wet coast of British Columbia. If you have a large eruption during a heavy rainfall, that volcanic ash can be can basically is wetted and becomes much heavier than it would otherwise be. So we've not really thought in our urban planning about the implications of volcanic ash on structures and things like that. By and large, we don't have to worry. We shouldn't have to worry about issues around roof collapse and things like that you would in other countries, say in Indonesia, where it's much more problematic.
Yeah, and thanks, Tobias, for that. And yes, you go to BC for vacation, you can do some volcano tours. Do you get a lot of people? Like, can you hike around some of these?
Um, you can get up close to volcanic deposits.
Okay.
The thing with the volcanoes in BC, um, again, one of the reasons why it's not really on people's radar is the fact that they tend to be large overlapping massifs of volcanoes, as
Mm,
opposed to your distinct, upside down
right.
ice cream cone, Mount Rainier in the U.S., Mount Fuji in Japan. So they're big, they're remote, and many people you can't even visibly distinguish it from just the background mountains. So hiking around a specific one is tricky, but if you go and find the more bite-sized volcanoes, what we call a cinder cone or a tephra cone, these are maybe only a few hundred meters high, maybe 100 meters in diameter. Those you can easily sort of hike around. And I'll give a plug, in fact, for this area that we've been working on, CX volcano. It's about like I said, I guess it's about an hour and a half drive northwest of Terrace.
Okay.
Very easy to access, and it's a provincial park. Um, so it's a beautiful area to walk around. They take tours up onto the
So that's up in
volcano.
here.
Yeah, so that's just at the bottom tip of belt number three of
Okay.
yeah. So you
Okay.
fly into Terrace and then drive from Terrace. Um, and yeah, it's very readily accessible. closer in sort of the lower mainland of British Columbia, you can go into the Garibaldi Provincial Park, where there are
Okay.
also small volcanic features. Opal cone is another little cinder cone that is very easy to walk around and see. So yeah, tourists and the general public can access that.
So, like, I guess I'm still very curious about what is the risk right now of, let's say, a big enough eruption that, again, an Edmonton to a Regina would need to be worried about ash flying over.
At the moment, we do not have a good assessment on
Oh,
that.
great.
Yeah.
I shouldn't have said anything.
No, look, it's important to say that.
I just mean I'm gonna
Yeah,
jinx it now and
yeah. There's some fundamental issues. Again, as we mentioned, for broadest impact, it's going to be large explosive eruptions like Mount Meager did in 2,400 years ago, Mount St. Helens in 1980. Um, those types of eruptions in the Canadian context are quite rare in time. But the big caveat is we don't have a good understanding of how often these volcanoes have erupted.
okay.
So if we look at the United States, the Cascades, the high Cascades of Oregon and Washington, those volcanoes have been much more active. So there's much more information about their past activity. So we can, as geologists and volcanologists, we can go and look at these ash deposits and then try to date those ash deposits, and then basically say, okay, um, every 100 years we get an eruption of this scale, and
Mm,
start to build just like we would do in seismology, looking
okay.
at say paleo earthquake studies or tsunami deposits, trying to go into the geologic record to understand frequency of eruption, scale of eruption. We need that critical information. We don't have that for Canada because the volcanoes haven't been as active, which is a good thing.
Hmm.
Um, but also they're typically remote, which makes studying them more complex, more difficult, more costly. And glaciers mess up the Canadian volcano
Yeah.
deposits. So a lot of the activity was under ice. A lot of the activity was, you know, deposits that might have been erupted. They erupted onto ice. The ice receded. That data is gone.
Yeah.
Or it's being eroded. The glaciers came through the system and destroyed the deposits. So the data is there, it's just a lot harder to find. So one of my colleagues, in fact, at University of Alberta, Britta Jensen, is sort of one of the leads in Canada looking at volcanic ash deposits and trying to better map out all of these volcanoes that we have in Canada and really better constrain that. But I couldn't give you any reasonable
Hmm.
assessment of risk right now. We just don't have the
Wow.
information. So we need to
Interesting.
do that work.
Yeah, and so I would imagine, because you mentioned earlier, there was some in First Nations recordings of deaths. I mean, you've probably looked into that history with some of the bands there.
Yeah, and I think this is actually a resource that is really powerful, um, in that there are observational data that are preserved in an oral tradition. So in the case of SEAX, um, it was relatively recent, and in fact, it's a bit esoteric, but the oral tradition and the observations by the community that were living there at the time is more um, robust than the carbon dating that we were able to do on
Mm,
the deposits from this volcano. Because while it wasn't written down, it was preserved in the oral traditions. It gives details about the events, and it wasn't done, with a scientific view to things. It was a general public, responding to this cataclysmic event. But those observations, in terms of when the event happened, we think it actually happened in the spawning season of the pink salmon
Oh,
on the
okay.
one river. So that starts to put some constraints, maybe July to September. The mention about poison smoke starts to tell us something about the event. But these observations have placed constraints that we can use on our modeling and come up with what we believe to be the most reasonable explanation for the different events. Um,
Yeah, and
so
so Chris is at so no 100
no,
year Okay,
no
that's
way.
actually good news, Chris, because if Fort McMurray gets hit with volcanic ash, you will automatically get disaster recovery program financial assistance because the government can't prove if it's extraordinary or not. So
Yeah.
that's good news for us. uh, do you know I've been to Haida Gwaii a couple times, and is I heard that Toe Hill used to be an old volcano. Do you know anything about that?
I don't know specific. It's quite possible,
Could
but
just be
how
a
old?
local rumor.
Well,
It's
no. I mean,
yeah,
there's a lot of volcanic deposits. Geologically, British Columbia is very young.
yeah,
So there are different areas. I've not spent any time there, so I couldn't say for certain. Um, but again, one of the things this is my plug.
yeah,
Um, where the United States Geological Survey has done a really great job, and more broadly in mapping, is the use and the public accessibility of a technique called LIDAR that many of
right,
your listeners may know about, where we're
yeah,
using laser range finding. And the beauty with that is, I mean, it's very, very powerful, say, for wildfire monitoring and management. But the ability to digitally strip away vegetation and look at a bare earth is an incredibly powerful tool. It allows, the problem that we have in BC is if there are volcanic remnants, often, unless you stumble on it, you don't know about it because it's a big empty province. The the logistics of just getting out there and mapping and covering areas in dense bush is problematic. But if you have comprehensive lidar, you can sit in front of your computer screen and find all these features and then do the targeted mapping. Let's go in here. We know that there's a feature. We can identify it, and that'll be our Mayan cities. The way they've discovered these in Mexico, we would have our volcanic examples in BC. So
right.
that's something that we could really benefit and would take a huge step forward in being able to catalog, identify these areas, and then move forward to be able to say, okay, we've got these areas. Let's go do targeted research. Let's try to find to maybe eventually come up with, as Chris says, a 100-year model if we can do the detailed work.
Yeah, no, yes, Chris, you are the you do cost Canada a lot of money up there through fires and floods and all the other good stuff. Absolutely. Uh, so I guess I had a question there, but it escaped me for a second because I was starting to laugh at Chris's comment. Um, doesn't do you engage at all with insurance companies or Insurance Bureau of Canada to try and get this on the risk radar?
Um, we're I've not done it directly recently. It's on my plate, on my radar of things to do. Again, so many hours in the day,
Yeah,
but it is something, and nationally, or rather internationally, the insurance agencies and bodies are recognizing that from a broad scope, we need to be thinking about natural hazards not only in the high frequency, high impact, but the low frequency, super high impact.
yeah,
So that 1 in 500 year large megathrust earthquake, the Hawaii being hit by two hurricanes, they these types of things. The volcanic situation in Canada is such. The low level of activity means that if we do get another eruption of Mount Meager, it could be on the same order or larger.
hmm,
We everyone is concerned about, say, Yellowstone in the U.S. Those huge eruptions, the largest volcanic eruption in the world, happened about 2 million years ago at Yellowstone. and it was
Right.
2,500 times larger than the 1980 eruption of Mount St. Helens.
Wow.
So those are truly cataclysmic events.
Yeah.
Thankfully, very, very rare. Um, so I think the insurance companies are starting to recognize that that type of work needs to be done, and I've seen some really novel ways. In fact, even preparing communities in advance, more on the sort of climate-related hurricane issues, of having insurance products
Hmm.
that can be used in advance to help prepare to build resiliency in those communities well in advance of a disaster, and so you mitigate that disaster. Um,
Yeah, because I mean, that's just one of those hazards that's going to creep up, and
but you,
yeah, 100%. If
yeah,
it's not talked about, how's anyone going to consider it? And it's another good reason why emergency disaster and emergency managers need to be really good generalists,
yeah,
because we need to have literacy in all of these hazards, science,
yeah,
systems, insurance, all that stuff.
yeah.
What resources are out there for general disaster and emergency managers, even ones in the healthcare field? What's out there right now?
So and again, this is a perfect point, because one of the other initiatives that we're trying to do is build a more centralized resource. What I've been seeing, again, I'm an academic ivory tower type, um,
Yeah.
but looking into this, and again, coming from, oh, I want my student to be able to find all the information on volcano X. Well, unfortunately, that information is scattered all over the place in a
Right.
range of different databases. And to date, unfortunately, a lot of the different resources tend to be domain specific. So there'll be, some amazing work for by Avalanche Canada, for example.
Mm.
Beautiful archive, accessible information. There's great resources for say, BC Wildfire Service. Um, but what we don't have is integrated data. And it was a telling point. I was speaking with a colleague. She's an emergency manager for Whistler,
Oh yeah.
and she really pointed it out. She said, in a crisis, so we had some smaller events, but it was a small wildfire around Squamish area, right in the middle of COVID. So we've got a cascading hazard to try to manage,
Hmm.
and she was saying, to respond, she had 17 bookmarks to try to get the different bits of information she
Sure.
needed to be able to respond.
Yeah.
So what we're trying to do at SFU, and again collaboratively, is build a one-stop shop, open access, and so much of that information is relevant across hazards. So
100%.
if we've got good LiDAR data, that helps wildfire preparation. It also helps volcano preparation, identification of potentially active faults that might generate earthquakes. So what we're trying to do is make a Canadian natural hazards data portal that is open access, that actually is a vehicle to allow citizen scientists to contribute, um, and also that is optimized for a range of different end users. So we're at the very, very early stages, but what we're hoping to be able to do, and again, I would hope that once we make some more headway, I can come back and reach out to some of your listeners, because um, we want to have something that addresses everyone's needs, which is a big ask.
Hmm.
Um, so what we're going to try to do is bring all of this data together, aggregate. We're not going to just be a black hole. We want to bring it together so it's accessible, and then have the best data possible, the most granular data possible, but then be able to produce products that are actually usable for decision makers, responders. So, tentatively, I'm seeing a beginner's button, an intermediate button, an advanced button,
Yeah.
and a something that a scientist is interested in is not going to necessarily, the same raw data is fundamental, but the level of granularity is going to be different. It's, you know, the difference between a hazard map and an impact map,
Right.
these types of things. So that's what we're working on. Very, very early days, but we are also going to try to engage with all of the different, as many different end users as possible, to see what do you want as professionals, what does the general citizen want, to be a more informed citizen. The COVID situation that we've been seeing really has highlighted this, that I want to see what are the trends, and I'm not an epidemiologist, but
Hmm.
show me some clear, simple, consistent data sets, and I
Yeah.
can make an informed decision. So this is where we're trying to go. It's going to be a huge job, but we've got great people, and we've got the computational infrastructure to make it work.
Darren, if you get an Excel sheet out right now, we'll see if we can get it done in the next half an hour,
Mm-hmm.
live on LinkedIn. No,
Yeah.
what's yeah, that's a huge. And so we'll get to Darren's question, but I was going to say, like, so when I worked for the Alberta Emergency Management Agency, the government of Alberta could never get onto a full provincial hazard identification
Yeah.
risk assessment for tons of reasons. But I would think, listening to you, one of those reasons is we do not have a one-stop shop for this information, and
Yep.
it's such a huge undertaking at a provincial scale, and you've got to engage every community in that type of assessment so they can work, bring the
Mm-hmm.
risk, the assessment down. Like this, I could see. So to Darren's question, like, what's a timeline for that?
Uh, you know
Best
what?
guess.
This is never going to be finished.
Yeah.
That's
Yeah.
the nature of these types of initiatives. Um, I'm we're starting. We've got basically software developers, database developers going right now, and the we're this is a research thing with an end goal. We're going to start small. So we'll focus on a couple of key areas where we already have a lot of information, especially with related to, say, cascading hazards. So Mount Meager, for example, is going to be an area of interest. Personal bias, absolutely,
Yeah.
but we'll expand. Um, it takes money. So that's why I've been writing these large grant proposals to do this. We cannot do this on a volunteer basis. I'm optimistic that we will be successful, because one of the things that we at SFU and the Center for Natural Hazards Research isn't encumbered by is legacy. So many governments, be they provincial, municipal, provincial, or federal, are stuck often in that legacy problem. We have this old system, and it's going to be far
Yeah.
too costly and cumbersome to migrate that. We're starting from zero.
Yeah.
So we're working on what are the best practices out there right now. We're also going to structure it in such a way that we use standards like there's the European Inspire standard. All geospatial data in Europe now has to be standardized so that your maps actually don't do this when you cross the
Right.
border.
Yeah. Yeah.
And the key thing is we want to build this system so that we can optimize it for smart analytics. So
Absolutely.
the
Yeah.
AI approach, that's where I think as an end product, we will be able to really leverage machine learning or
Yeah.
artificial intelligence approaches to get into those telltales. I'm, from an academic perspective, really interested in, can we tease out subtle precursory signals if I've got all of the different data. I've got weather data, climate data for the last 2 decades, and I've got this deformation data for the volcano, and etc. So that's where we're hoping. It's not going to happen tomorrow,
No.
um, but we also, again, want to try to bring in all of these other. The citizen scientist is a resource that is, I think, in the natural sciences has been, aside from the life sciences, biologists have done a stellar job of it. But I think in the earth sciences, we've not really tapped into that resource. And I think that's something that really I'm really passionate about trying to get going. It'll be
Yeah.
fun too.
Yeah, I know. I sense that from you. Because I know you've got fatherly duties that you've got to go to in about 3 minutes, and I have a sense that you could have kept we could go on for another hour at least.
Oh, easily.
Yeah. So, okay. Let's just end with, how can the other disaster and emergency management leaders out there support you or contribute to what you're doing?
So, um, I would flippantly say send me some money, but no, realistically, what I would goodwill.
Goodwill, yeah.
Eventually, I'm going to be reaching out to the broader communities to say, um, here is what we've got. Are you willing to collaborate? And the more information that you can help put into the system, the that is going to make it more powerful, more usable. In the very short term, I really want to be able to find out what is most pressing for you as professionals, as end users. So we're very focused on this idea of not doing a top-down paternalistic approach to things.
Mhm.
This is what you need. No, you know what you need. Tell me what you need, and we will try to come to an arrangement so we can actually provide a true resource. If this can be even operationalized, that will be fantastic. But at the very least, it will all be in one spot. And some of it will be aggregating, will be pulling data sets in from other areas. We don't want just a give me all your data, thank you very much. Give me a link to the data that is public, that is willing to share, and help us come up with the tools to make that data intelligible, interrogatable, and actually at the end useful in a crisis. That's what we want to do. So a big ask, a big job ahead of us, but I'm confident that we can do it. We've got access to so many really bright people, full of energy, far more energy than me.
I don't know about that.
You should see some of my students.
Yeah, I bet. Well, I'd love to have you back on
Yeah.
and be able to spend a little bit more time talking around, because I'm really happy that we went from, talking just volcanoes to getting into the broader picture about hazards and that centralization of information. Because I know, you're at the pivotal point of hazards and risks in at least Canada and in the industry. And it's people like you and academics like you that can bring a lot to that operational level. And so I really appreciate you, being able to spend time to talk about this.
Well, no, thank you for having me.
Yeah.
This has been a great opportunity, and spread the word.
Yeah, we will spread the volcano word. I'll start a volcanic or a centralized database wishing well fund, and
Perfect.
we'll see what we can get.
Yeah.
So, all right. Well, thanks everyone for tuning in. I will have Dr. WJ back on in the fall, maybe, or early winter, and he's got to go and do some fatherly duties. So stay connected out there, and really appreciate you tuning in today.
My pleasure. And again,
Thank
if
you.
people have got questions, feel free to contact me via LinkedIn or off my webpage. You can find me at sfu.ca.
Yeah, well, I should have asked where we can find you. So yeah, Google your name. I think you've got a LinkedIn profile. Yeah, okay.
Perfect.
Awesome. Thank you, and yeah, stay connected, everyone.